This lesson is titled Function Rules, Tables, and Graphs. There are three views of a function. We can look at the function equation or rule. We can look at the function table. And we can look at the graph. If we're going to get the graph, we're just going to start plotting points. So here's negative 5, 3, negative 5 up 3. Here's negative 2, 3, negative 2 up 3. 0, negative 3 is down here. 3, 3. 531 we can't see. And 833 we can't see. And then the graph, if we plotted all the points, they would follow this path. So every function has three views. We've got the rule, we've got the table, and we've got the graph. Here's an example. We're going to model the function rule y equals negative 1/2 x plus 1 using a table of values and a graph. Let's start with the table of values. We've done this before. We can pick our own domain here, though, and then just calculate the range. So let's try negative 2. We plug in negative 2 and 0 and 2. That'll give us three values for this linear function. If we plug in negative 2, we're going to get 2. If we plug in 0, we're going to get 1. If we plug in 2, we're going to get 0. If we go to the graph now, plot those 3 points and draw the line. There's negative 2, 2, 0, 1, and 2, 0. Now let's just draw the line through those points. So we've modeled the function using a table of values and a graph. You try one. Go ahead, pause the video, and try to model this function with a table of values and a graph. When you're ready to check your answer with mine, press play. Let's see, let's set up a table here. It looks like we've got a linear function. I can tell that because it's just x to the 1 power, or you can't see a power here. If that's the biggest power of x, we know we're dealing with a line. We've got x's, we've got y's. Let's make sure when we try to lay this out, we try at least one negative number, we try at least 0, and at least one positive number. When I put in negative 2, I get negative 6 plus 4, which is negative 2. When I put in 0, I get 4. And when I put in 2, I get 6 plus 4, which is 10. So I should be looking at negative 2, a point about right here. 0, 4, 1, 2, 3, 4, a point about right here. And 2, 10. Here's 2, 5, 6, 7, 8, 9, 10 right here. So my line should connect all these dots. There we go. How'd you do? Continuous quantities. Quantities that are measured are continuous, such as temperature of water as it's heated from 60 to boiling. As the water is heated, it does not jump from 60 to 61 degrees. It goes to each little measure in between, every decimal or fractional measure in between. It takes on every temperature between 60 and 61. A discrete quantity are quantities that are counted, such as the number of people entering a library. You shouldn't see a half or a third or a tenth of a person entering the library. It goes from the 60th to the 61st person. It just jumps. Classify these as continuous or discrete. The water level in a sink as it's being filled. Is that going to be continuous or discrete? You should say continuous because it'll go through every little height along the way. It won't just jump from 1 inch to 2 inches and so on. How about the speed of a car? That has to also be continuous. You don't jump from 10 miles an hour to 11 miles an hour. You go through all the little decimal measurements in between. How about the goal scored during a soccer game? Well, you can't score a goal and a half. You score 1, then 2, then 3. So that's discrete. How about, say, count or measure? So if something is continuous, would you measure or count the water level in a sink? Well, of course you would measure it. How about the speed of a car? Well, you would measure that. How about soccer goals? You count those. So notice continuous things are measured and discrete things are counted. Determine whether the function rule models discrete or continuous data, then make a table of the graph. We have an automatic photo booth that charges $3 for a sheet of photos. The function cost of P is equal to 3P. Describe the cost of P sheets of photos. Well, let's see. If I can have 0 sheets, 1 sheet, 2 sheet, 3 sheets, and so on. So then my cost Well, if I have 0 sheets, I have $0. If I have 1 sheet, 3 times 1 is $3. If I have 2 sheets, that's $6. If I have 3 sheets, that's $9. So this is looking very discrete. It jumps from 0 to 3 and 3 to 6. I can't buy a half a sheet, so I'm not going to have anything between 3 and 6. So if this is my number of sheets, P, then this is my C of P, cost. So if I look at 1, 2, 3, 4, or 5, I should see along here. Let's just look at 3. Let's go by 3s here. 6, 9, 12, and then up here that'll be 15. So we would have 0, 0. We would have 1, 3, 2, 6, 3, 9. If we plugged in 4, we'd get 12, and if we plugged in 5, we'd get 15. So we just have this series of points. This is very discrete. We wouldn't connect those because it's not continuous. Families of functions. This is a really important concept. Anytime you see something with just an x power or just an x squared power or an absolute value, that is telling you a lot about the shape of the graphs of these functions and their behavior. So when we see just an x power, we need to realize that that graph has a certain shape, just like when we see these other things happen. If it's just an x, it's some kind of a line. It may not be this exact line, but it's some kind of a line. If we see an x squared, it's some kind of parabola that either opens up or down. If it's an absolute value around the x, then it's some kind of v. It either opens up or down. So if we know this about the graphs before we go to graph them, it sure makes it a lot easier to graph them. So try to become familiar with these families of functions: the linear, the quadratic parabolas, and the absolute value v's. In this example, well, actually this is a u-try, and we need to try to graph this. So go ahead and try to graph this, and then when you're ready to check, press play again. Well, when you're trying to graph and you don't know what to do, you should always just make a table. Let's try some values where x is negative. Let's try 0, and let's try some values where x is positive. This is not just a simple line. This is a v, so I'm going to try more than 3 values. So let's see what we get for a domain here. When x is negative 2, absolute value is 2, plus 1 is 3. When x is negative 1, absolute value is 1, plus 1 is 2. When x is 0, the absolute value is 0, plus 1 is 1. When x is 1, 1 plus 1 is 2. When x is 2, 2 plus 1 is 3. Now let's go ahead and plot these points. I've got negative 2, 3, 1, 2, 1, 2, 3, the point right here. I've got negative 1, 2. Oops, I missed negative 2, 3. I hit negative 3, 3. Let's get it on negative 2, 3. I've got negative 1, 2 right here. I've got 0, 1. I have got 1, 2. And I've got 2, 3. Can you see the V? It just appeared. This is the bottom of the V, and it goes up on either side, right through these values. How'd you do? Remember, if you ask to graph something and you don't know how to graph, make a table of values and then pretty much just connect the dots. That's really helpful to connect the dots if you know that this shape, formed by an absolute value, always gives you a V, because you can just look for the V in the dots. Let's go to the next one. Y equals x squared plus 1. Let's give this a shot. Okay, one thing we expect here is we expect to see a parabola. Kind of looks like this, or it could open down. This one opens up because it's positive here. So let's create a table of values and see if we can see that thing appear. Let's again try these same values: negative 2, negative 1, 0, 1, and 2. When I plug in negative 2 and square it, I get 4 plus 1 is 5. When I plug in negative 1 and square it, I get 1 plus 1 is 2. Plug in 0, I get 0 plus 1. Plug in 1, I get 1 plus 1. Plug in 2, I get 4 plus 1 again. So I get these values. Negative 2, 5. 1, 2, 3, 4, 5. Negative 1, 2. 0, 1. 1, 2. And 2, 5. 1, 2, 3, 4, 5. You can see it kind of has that V shape, but it's got a turn here to get up to that other point. So it's not a V, it's a parabola. So we're going to draw that parabolic type curve through here. It looks something like this. How'd you do? Let's try this one, y equals 3/4 x plus 2. Why don't you go ahead and pause the video and you give it a try, and then press play to see how you did. Okay, what I would do, again, I just create a table of values. This is a line. It's linear because I just have this x. So I don't need as many points. I'm going to do 3. One of them becomes a check that way. I'm just going to use -2, 0, and 2. Actually, let's use easier values to work with on the fraction. Let's use -4, 0, and 4. Why -4? Well, because 3/4 times -4 is just -3. That gets rid of the fraction rather nicely. -3 plus 2 is -1. 0 just zeroes out the whole thing and gives me 2. If I put in 4, 3/4 times 4 is 3, plus 2 is 5. So now I have my 3 points. -4, -1, 2, 3, 4, -1 is right here. 0, 2, right there. And 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5 right there. These points should lie nicely on a line. Just connect them up here and draw our line. How'd you do? That's our learning target for this lesson. I'll see you in class.